Alright, welcome back. We're back doing PLC-IO sim challenges. And we're on number 19 here, the timed stoplight. Before we get started, why don't you smash like and subscribe. Okay, design a program to control a stoplight using timers. Momentarily pressing the start button begins the sequence. During the sequence, the lights will alternate between red, yellow, and green for 2 seconds each. The cycle will continue until the stop push button is pressed. Step 1, turn on the red light. So, I'll get my start button, and I'm going to get to latch the red light on. What I'm also going to do is make a new line and have the constant signal of the red light activating this on delay timer for the next light. So this way, as soon as the red light turns on and latches, this timer will start counting. And once it hits 2 seconds, 2000 milliseconds, we have its done bit, which will become closed. And that done bit can be used to do 2 things. So we'll make a parallel branch. We'll have that when this timer is done, the red light unlatches. And we'll also have it so that the next light latches. So that'll be yellow. Okay, so we'll make a new line, and we're just going to repeat this process. So now that we have a steady signal from the yellow light because it's latched, we will use that to give power to timer number 2. And once that timer has been on for 2 seconds, its done bit should toggle, and we want that to do 2 things for us. We want that done bit to, first of all, unlatch the yellow light. We want it to, second of all, latch the green light. Okay. Now what do we want to do? We want to do the same thing. So, now that we have a steady signal from the green light, because it's latched, we can use that to maintain steady power to this timer number 3 so that it can start counting as soon as the green light turns on. And what we're going to do is when timer number 3 hits done, we're going to do 2 more things. We're going to unlatch green. So let me find this. Unlatch green. And we also want to latch red again. So I will just put that down here. Latch red. So I just want to quickly see if this works. Okay, that's beautiful, but we don't have any way to stop it. So let's quickly add our stop circuit. And what we're going to do is we'll put our stop contact, again, normally closed because the stop button is normally closed. That means this input is energized, and so this will be negated. So this is actually normally open. Okay, and what's going to happen when we click stop? We're going to want to unlatch all of the lights. So boom, boom, boom. Unlatch red, unlatch yellow, and unlatch green. Alright, and let's see if that works. So the cycle's still going from before, so I'm going to do the stop command. Sequence is done. Go with the start command and watch the magic. That one was definitely the trickiest one yet. Took me a while to figure out. I did it off cam. So yeah. I guess we'll just move on to the next one. Alright, let's head on down. Here we are. Counting conveyor. Design a program to count the number of items entering and exiting a conveyor. Pressing start energizes both the conveyor motor and gate. The motor and gate should stay energized after releasing start. Okay, so I'll just make that right now. Start is going to latch both the motor and the gate. Pressing stop should de-energize both the conveyor motor and gate. So we'll make that as well. For the unlatch, and we have two sensors. Prox1 will count the things entering, and Prox2 will count the things exiting. Okay, so I'm assuming that they're, yeah, here they go, normally open switches. So every time something goes past it, it'll click. So we'll just add a new line with some bit for Prox1. So that'll close every time something passes this first sensor. So we'll be wanting to count that with the entering counter. Same thing for the Prox2 bit. Will go off every time something exits the conveyor. And we'll have that increment counter number 2, which is the exiting counter. Alright, let's see if we got it first try here. So start should latch both of the things, the motor and the gate. Not sure what the gate is, but yeah, you can see we're counting the things entering. And when they get to the end, counting the things exiting. Wonderful. So let's see if our stop button works. All good there. Let's power on to the next one. Stack light. Okay, design a program to control a stack light. The stack light will depict the status of a conveyor motor and the number of items on the conveyor to an operator. Uses a counter to keep track of the number of items on the conveyor. PB1 should indicate that the conveyor is running and turn on the blue lamp. Okay, let's do that right away. So PB1 will simply be tied directly to the blue lamp. So if you press PB1, this light will turn on. That way you know the conveyor is running. PB2 should increment the items on conveyor. PB3 should decrement items on conveyor. Okay, so we'll make PB2, and we'll need a counter, a count up, to increment the items on the conveyor. And we'll need a PB3 to count down, CTD, also items on conveyor. If the items on conveyor accumulated value, so that's ACC, is less than 7, then the green lamp should energize, indicating that more items can be added. Okay, let's do that. So we'll set the preset value of items on conveyor to 7. That way, when we get up to 7, the done bit will turn on. However, we want the green light to be on if we're not up to 7. So we'll use a normally closed bit that will open up when the ACC reaches 7. And that will control the green light, indicating that there's more space. Okay, where are we? If the items on conveyor ACC value is greater than or equal to 7, but less than 10, then the yellow lamp will energize, indicating that the conveyor is approaching its capacity. Okay, so there's a couple ways of doing this, I think, but we'll make a series combination here. So if items on conveyor is done, that indicates that the value is greater than or equal to 7. But we also need the value to be less than 10. So I'll make a comparison here. Less than. And we're going to be using items on conveyor ACC value. Oh, and we'll have to make a variable for 10, it looks like. They don't give you the option. So I'll quickly just make a dint variable, double integer, that will represent 10. And there you go. So if the ACC is greater than or equal to 7, this done bit will turn on. And if ACC is less than 10, then we should be able to activate this part. And there we're going to put the yellow lamp, indicating that we're nearing the end of capacity here. Now, if items on conveyor ACC is greater than or equal to 10, then the red lamp should energize, indicating that no more items can be added. So there's also a couple ways of doing this, but I'm going to do it this way. So the red lamp will turn on if the yellow light is off and if the green light is off. And that's because if the yellow light and green light are off, that means the value is not less than 7. It's also not greater than or equal to 7 and less than 10. So if both these lights are off, that means the value is 10 or greater. All right, so let's give it a go. You can see the green light's on because the ACC is less than 7. That means we can still add things. So let's turn on the conveyor with PB1 here. You see the blue light turns on. Click PB2, you see ACC is going up on the counters. When we hit 7, it should switch to the yellow light. And as we keep going up, if we hit 10, we should hit the red light. Yeah, that's not good. So let's remove some items. Go back to the green. Beautiful. And that's how that's done. Okay, on to the next one. Stack light 2. So this is the same as the one we just did, but they want us to use a double integer to keep track of the number instead of a counter. So to do this is just a bit different. We'll still use the push button, for example, and we'll have to use that add function. But there's a bit of a problem. If we want to do items on conveyor +1 every time we click the button and move that to items on conveyor, you'll see there's a bit of an issue. If I just quickly press the button and release it, and I go and read the value, it's already counted up to 9. So you can see if you just hold the button down, it will keep adding these values every scan. So we need a way to just add 1 every time we click the button. And this is where the one-shot variable is going to come in. So if we add our push button again, and we add it in series with the one-shot command, and we do that into our addition box. So items on conveyor +1, move that to items on conveyor, and we'll go to run mode. First of all, you see when I hold PB1, the counter is equal to 1 and it's not going up. So press it 2, 3, 4, 5, and boom. So this one-shot command will emit a signal for just one scan. So even if you hold the input, it will only emit one output. So that way you can just add one at a time. So here's my final logic all programmed in. The only difference is these one-shot commands going into the add and subtract to change the value of the double integer. For the sake of time, I just already programmed all of this, but it's all working exactly the same as the last one. Alright, that's all the time we have for today. Smash like, subscribe, check out PLC IO Sim, very cool. Yeah, we'll pick it up on Manual Mixing Tank on the next one.